Okay, let's start things off. First off, I'm going to introduce myself. Hello, my name is Lance Zurich, and I am the product manager for the fischertechnik education division over here at Studica. And today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in CTE training, a college professor or industrial trainer teaching programming skills required in manufacturing, a company looking for ways to demonstrate their software-based solutions, or someone looking for ways to make IoT-related concepts easier to understand to employees or customers, I believe this presentation will offer some important options for you to consider. Let's start off by considering the skills gap. If you've attended any of our other fischertechnik education webinars, you've probably heard me discuss the importance of STEM education. STEM, of course, is an acronym for Science, Technology, Engineering, and Mathematics, and it should go without saying that STEM education has been perhaps the most discussed topic in education for the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help to best prepare them to take their place in the modern workforce. Not so long ago, when our parents or grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. Now, as it ties in directly with the solutions we will be looking at in this presentation, let's consider that last skill area that I just mentioned, that of a PLC programmer. Now, first off, for anyone who may not be familiar, let me explain exactly what a PLC is. Now, the term PLC is also an acronym, the letters of which stand for Programmable Logic Controller. Essentially, a Programmable Logic Controller, or PLC, is a very specialized computer used to control the types of machines and automated processes typically found in an industrial setting, such as an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. Now, to get a clear idea of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, "The average PLC programmer salary in the USA is $78,000 per year, or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year." End quote. In fact, a quick glance at the first page of job openings for PLC programmers on nuvu.com for the date of February 27th of 2020, when I originally prepared this presentation, showed 15 positions being advertised with salaries over $75,000. Now, 2 of these listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and the university level. And at the same time as this workforce of tomorrow gets their training, more and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools offering such programs. So how long does it take? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient in all 5 of the most widely used PLC programming languages, such as you see listed here, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are many other options available. High school CTE, career and technical education programs. There are adult continuing education programs, vocational training, technical training and trade schools, and employer-sponsored incumbent worker training programs. Now, this all being said, the question that still arises for the educator, and that's whether in the university or the vocational school classroom, is How do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it more realistic and hands-on? But there are other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding different types of automation and control systems. Now, it could be a company involved in creating or marketing a new type of software-based solution that it's looking for ways to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show. Now, in each of these cases, and of course many more, there's a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of fischertechnik industrial simulation and training models. Now, these models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled, small-scale models which are designed to replicate, in both appearance and function, various automated robotic machines and systems commonly used in commercial manufacturing. Now, before we look at each of these models, let me provide you with a little bit of background. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years based around their unique building system. Now, what makes their building system unique is that unlike other popular construction systems where the components are designed to simply stack, fischertechnik was created with more of an engineering mindset. The core building block in the fischertechnik system is designed to enable attachment from all 6 sides, and thus it allows for almost limitless design possibilities. Now, many of the parts in the fischertechnik system are designed to slide together and lock in place, and the hundreds of different parts available will also help you to address very specific design needs. The fischertechnik system was created back in the 1960s by German inventor Arthur Fischer, noted for countless innovations used in the construction and the automotive industries. Now, Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Besides fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, which was back in 1949, and he was also the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction. They also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik education sets, whether those intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology. Now, many of the products offered by fischertechnik for the education sector are subject-specific sets, focusing on different STEM-related areas, things like mechanics, pneumatics, robotics, or renewable energy, just to name a few. Now, in many of these sets, students are asked to build a progression of models using the unique fischertechnik system, and then perform various experiments which allow them to explore and understand aspects of that subject. Now, there are also sets designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based programs, students dive deep into engineering and learning all aspects of the design process, which requires them to work in groups and create various devices and automated machines to meet the criteria put forth in a series of real-world scenarios based upon their own trial and error experimentation and research. Now, the line of fischertechnik simulation solutions, which are of course the focus of today's presentation, are something much different. The line consists not of kits, but of a series of pre-assembled, small-scale models, which again replicate in appearance and function various automated and robotic machines and systems. Models in the fischertechnik simulation line include things like conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and high bay warehouse storage systems. Now, besides these individual models, which focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. Now, this model consists of 4 individual workstations, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, which all work together as one self-contained material cycle. And of course, we're going to look at that in a little while. But before we begin to look at the models in the simulation line in more detail, let me briefly outline some of the advantages of using fischertechnik solutions. Now, I will apologize in advance for the first few points because there are things I mentioned before, but in each case, I do think it's worth repeating. First, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible, physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, in both appearance and function, common automated systems, things such as conveyor belts, sorting machines, robotic arms, and more. Because the models are compact and in most cases they're tabletop size, these are not only ideal for use in the classroom or in office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next factor is quality. Each fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each model, each model in the line is currently available in 2 different versions. The first version is a 24-volt version, which is designed for use with industry-standard PLCs. Now, whether you use Allen Bradley controllers, Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or others, you can control these 24-volt versions with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language, such as the ones you see listed on the screen now. Please note that with the 24-volt versions, no PLC is actually included, and all programming and programming guidance, as well as any power sources or other hardware, are the responsibility of the end user, with one exception, which we will discuss later. Of course, this should not be an issue, as these models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. On the other hand, for non-industrial users and educators not versed in or familiar with PLC programming, there are also 9-volt versions of each of these models that are available. Now, these 9-volt versions ship pre-wired to fischertechnik's own proprietary robotic controllers, which are called the Robotics TXT controller. And each of these controllers is pre-programmed using fischertechnik's own RoboPro graphic programming software. With these 9-volt models, the only additional component required will be the addition of 1 or more 120-volt power adapters as specified with each model. Otherwise, in most cases, these should be ready to use right out of the box. If you are involved in demonstrating or exploring IoT, also known as the Internet of Things, besides the fact that many end users have adopted many of the models in the primary line of simulation and training solutions for IoT purposes, fischertechnik now also offers a special IoT-focused version of the factory simulation designed specifically for exploring and understanding cloud control and what is sometimes referred to as Factory 4.0. In this case, the model is designed to be both controlled and monitored from a special web-based dashboard. We will, of course, discuss this in much more detail later in this presentation. Finally, fischertechnik simulation models are cost-effective. Now, while I won't get into naming names, I will say that if any of you have looked into any of the other hardware-based industrial simulation options that are available in the marketplace, you'll probably notice that the entry point for many of these products can easily be $20,000 to $30,000 or even much more. Fischer-Technic simulation solutions, on the other hand, are only a fraction of that price, as well as being compact, realistic, and high-quality learning and demonstration tools. So on that note, let's look at each of the models which are available. The first model we are going to look at is the vacuum gripper robot. Now, as you're going to see in this presentation, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you'll see in the video, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds. Now, the 24-volt versions of this model, as well as the other 24-volt versions we're going to be looking at, each have a relay board for motor polarity reversal and both a multi-pin connector with 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as with all of the 24-volt versions, will require you to provide the PLC and the programming. The 9-volt version, which is the version that you see being used in the video, will once again come wired to the Fischer-Technic Robotics TXT controller and will ship fully programmed using RoboPro graphic programming software. Now, if you wish to create your own programming, individual licenses of RoboPro are available on our website. Otherwise, for this 9-volt version, only the addition of a single 120-volt power adapter will be required. I will also mention that for this and all the other models we're going to look at today, the specs are also detailed in the product listings found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of the presentation. Next up, we have the automated high bay warehouse. The model features a transfer station with conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, and 9 individual storage spots. Components of this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 phototransistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each of the pieces. I will note that this model is a favorite among educators I've talked to who are teaching programming, and the reason for this is because it gives you a lot to work with in regards to the movements of the picker mechanism, as well as the precision required to properly store and retrieve each piece, each step, of course, which will, of course, require its own specific coding. Now, the dimensions for this model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds, depending on which version we're talking about. Once again, the 24-volt version of the model has a relay board for motor polarity reversal and both a multi-pin connector, 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide your own PLC and programming, and the 9-volt version, again, is pre-wired to a pre-programmed Robotics TXT controller, and one 120-volt power adapter is required. The next model in line is the multi-processing station with oven. This model features a furnace simulation with a pneumatic sliding door, as you'll see in just a second. There's a downstream processing station with a pneumatic transfer unit, which includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 phototransistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 inches by 14 by 12 inches, and it has a weight of about 11 pounds. Again, it's available in both 24-volt versions for use with the PLC of your choice, and the 9-volt version, in this case, is connected to 2 Robotics TXT controllers. So in this case, 2 120-volt power adapters will be required for all operations. just let this play for a little bit more. And there you go. The next model in our progression is the sorting line with color detection. Now this simulation, without the sound, this simulation features a system for detecting work pieces of different colors, and it sorts them via a conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as with the models we've looked at before, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, you need to provide the PLC and the programming. The 9-volt version, once again, comes pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is required. The next model is the factory simulation, which combines the 4 models we've just reviewed: the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection into one self-contained material cycle. The cycle will work like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then move to the multi-processing station with the oven. After the workpiece has been processed by this machine, it is then sorted by color in the sorting line with color detection, before again being moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've already discussed the components of each model previously, I won't belabor it by restating them here. What I do want to discuss are the dimensions of this model as a whole. Again, as it combines 4 individual models into one cycle, it has a much larger footprint. In this case, approximately 39 by 31 by 16 inches. And in this case, the weight is between 43 and 46 pounds, depending again on whether you're ordering the 9-volt or the 24-volt version. Now, due to these dimensions and the fact that it's again a pre-assembled model, please note that this model will only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models tend to be in very high demand, please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. Now, a few other things to note. First, this is again available in both 24-volt and 9-volt versions. Now, in this instance, the 9-volt version is wired to 5 robotics TXT controllers. But because of the way that a couple of the controllers are daisy-chained, it will require 3 120-volt power adapters. Now, as always, the 24-volt version will require the end user to provide all PLCs and programming and any other hardware which may be required. Again, each station on the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the 2 factory simulations we've just discussed who may need to transport the model or who wish to protect it when not in use. Now, the travel case consists of an aluminum casemaker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion is lined with hard foam. It's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of approximately 53 pounds without the factory in it there. So once again, if you put a factory in there, you're looking at approximately 100 pounds total weight. Please note that even when using the travel case, these models will still need to be shipped flat, unlike the way that they are standing up in the image here, unfortunately. The next model is a basic conveyor belt. Now, this is a transport belt with a length of 275 millimeters that is used to transport workpieces with a diameter of up to 29 millimeters each. Multiple conveyors can easily be connected to increase the length of transport as desired. Now, components on this model include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions of this model are approximately 14 by 10 by 4 inches with a weight of under 2 pounds. Now, as before, this is available in both 24-volt versions as seen here, and also 9-volt versions connected to the robotics TXT controller as shown here. In this case, one 120-volt power adapter is required for operation. The next model is a variation of the conveyor belt, which includes a punching machine. Now, this features essentially the same conveyors we looked at, except this time with a machining station built in. Components of this model include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 17.5 inches with a weight of about 3.5 pounds. Again, it's available in both 24-volt variations as shown here, and the 9-volt version, which is wired to the robotics TXT controller, again requiring one 120-volt power adapter. The next model is the indexed line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts, as I just mentioned, 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions of this model are approximately 19 by 18 by 11 inches with a weight of about 8 pounds. Again, it's available in both the 24-volt version for use with PLCs and a 9-volt version wired to the pre-programmed robotics TXT controller and requiring one 120-volt power adapter. Next is a variation on the idea of a pick-and-place robot, the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or backwards 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions on the model are approximately 19 by 16 by 9 inches, and it has a weight of about 6 pounds. As with the other models we've looked at, this is again available in both 24-volt versions for use with the PLC and programming of your choice, or also a 9-volt version wired to a pre-programmed robotics TXT controller requiring one 120-volt power adapter. Now that concludes our look at the first 9 variations of simulation models, all of which are available in both 24-volt versions and 9-volt version. The next simulation model is designed specifically to address the topic of cloud-based monitoring and control. This is the Training Factory Industry 4.0. This model is designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a large scale. Now, as the following video provides a nicely narrated overview of all the details of how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The 6 fischertechnik TXT controllers control the learning factory. The controllers communicate with each other via standard MQTT protocol. The controller programs are written in C, C++, and the controllers arrive with the programs already loaded on them so that they can be used right away. The programs can be changed and customized. The sensor image data are used and monitored in the fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The high bay warehouse is organized chaotically. There is no fixed space for a material to be stored. The system simply recognizes the next available space. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Fairly impressive, I think you'll agree. Now, the following topics can be addressed with the fischertechnik Training Factory Industry 4.0 model. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, and digital traceability with NFC/RFID technology. Customized production in lot size 1. Integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, connection of upstream and downstream logistics processes, and for experts, the creation of your own unique programming using C, C++. Now, as you just saw, the model incorporates many features not found in the models we've previously discussed, besides just, most notably, the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each of the individual workpieces, each of which has a unique identification number, which enables the positions of each workpiece in the cycle to be mapped, and the use of MQTT, message queuing telemetry transport, that allows the network TXT controllers to communicate with each other. Now, as discussed, this model is currently available in a 9-volt version, with the control facilitated through the use of 6 robotics TXT controllers. Now, unlike all the other 9-volt versions we've looked at previously, these are programmed not using RoboPro, but instead using C, C++. Again, all of the programming with this version is preloaded so that once again the connections to the internet and the cloud-based dashboards are made, all of which are clearly outlined in the downloadable documentation PDF, and you should be able to get started quickly. Dimensions for this model are approximately 39 by 31 by 16 inches, and it has a weight of approximately 53 pounds. Now, in this 9-volt version, which we've just looked at, will require the addition of 3 120-volt power adapters, will require the ability to access the internet, of course, as well as a tablet or a device for accessing the cloud-based dashboard. Now, as with the 2 factory simulation models, which we discussed previously, we recommend the travel case to help protect the model during storage or transport. Now, luckily, we're also happy to announce that as of August 2020, the 24-volt version of the Training Factory Industry 4.0 is also available for shipment. Now, while the 24-volt version is in many ways similar to what we've just discussed, let me very briefly outline what makes it a little bit different. First off, the 24-volt version is a bit of a hybrid in that while requiring a PLC for operation and control, it also incorporates one fischertechnik's robotics TXT controller. Now, in this case, the TXT controller serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC U8, also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. In addition to the TXT controller which is used on this model, there is also an IoT gateway using Raspberry Pi with Node-RED. This allows the option for not only presenting and using data on a dashboard in the fischertechnik cloud, as we've seen with the video of the 9-volt version, but it also allows you to display data and calibrate the stations of the factory in a Node-RED dashboard, as seen here. Now, this model also incorporates the newly developed 24-volt adapter boards to interface to the PLC. These, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, aka push pulse width modulation, and they also have push-pull output stages for phototransistors and buttons. Finally, one of the most important new features Now, unlike any of the previous 24-volt version models we've discussed or looked at today, the new 24-volt Training Factory Industry 4.0 also includes access to a sample program. Now, in this case, the program in structured text format was created based upon a Siemens S7 1500 PLC, and this program is available for download on GitHub. Of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program. The source codes needed for this are also available for download from GitHub, and of course, all the instructions are included with the PLC, or with the training model. Now, all of this information and much more is included in the 152-page PDF manual, which can be downloaded from the fischertechnik website. And that's a look at the Training Factory Industry 4.0 in both the 9-volt and the brand new 24-volt version. Of course, you might be wondering how much these models cost. So let's take a quick review of each option we've just discussed, along with the pricing for each of them. First off, you have the vacuum gripper robot. The 24-volt version of the vacuum gripper starts at $899 per model, and the 9-volt version is $1,199 each. The automated high bay warehouse in the 24-volt version is $1,035 list price, and in the 9-volt version is $1,319 list. The multi-processing station with oven in the 24-volt version is $989 each, and in the 9-volt version is $1,479 each. The sorting line with color detection in the 24-volt version is $819, and in the 9-volt version is $1,129. The factory simulation 24-volt version is $3,729 each. The 9-volt version is $5,239 each. The conveyor belt. Each 24-volt version is $220 each. Each 9-volt version is $519 each. The punching machine with conveyor belt, 24-volt version is $289 each. The 9-volt version is $599 each. The 3D robot, 24-volt version is $829 each, and the 9-volt version is $1,099 each. The indexed line with 2 machining stations, the 24-volt version for this model is $879 each, and the 9-volt version is $1,399 each. And the Training Factory Industry 4.0 for teaching, exploring, and understanding IoT-related functions, the 24-volt version, brand new, just released this month, $7,365 each. The 9-volt version, $6,495 each. Other items that I've discussed throughout the presentation, the 120-volt power adapters used for powering the 9-volt models are $12.99 each, $12.99 each. And the travel and storage case, which is used for all versions of the factory simulation and all version of the Training Factory Industry 4.0, whether it's the 9-volt or the 24-volt versions, you can use this for each of those. These are $1,000 each. So if anyone did have any questions, this is where I would allow you to type them in the Zoom webinar chat window or the question and answer window, which is also on your Zoom toolbar. I will check because I know we want to run things along here, not keep everyone going once, going twice. So let's talk about taking the next steps. Well, you could request a full color brochure and current pricing. You could ask questions directly. You could request a quote, or you could speak with your dedicated educational representative. You can do all of these things by calling us at Studica in the US. Our number toll free is 888-561-7521. You can also email us. Our email address is info@studica.com. Or if you have any questions about anything specifically I've discussed today, any aspect of any of the fischertechnik simulation models, or any aspect of anything fischertechnik related, you can also email me directly, and that is my direct email address, lance.zurek, lance.zurek @studica.com. So on that note, I'd like to thank you all very much for attending today's presentation. Have a great day, stay safe, and we look forward to seeing you soon.